Hello students, welcome in the series of lectures on application of partial differential equation. This is part 6. In this lecture, you are able to understand what is DAlemberts formula and how one can find the solution of one-dimensional wave equation by using the DAlemberts formula. So let us start. DAlemberts formula. Basically, there is a specific condition under which this is used to find the solution of a one-dimensional wave equation. This method is used, or this formula is used to find the solution of one-dimensional wave equation in an infinite domain. This is very important here, that the meaning of infinite domain is what? When the length of the string is from minus infinity to plus infinity, that is infinite length string. Generally, we will take the string of a finite length and we will find its solution by using the method of separation of variable. Here the restriction is that the string is the of having infinite length, or we can say the length of the string is belonging from the infinite domain. According to DAlemberts formula, the solution of one-dimensional wave equation, which is written as del 2u over del t square equals to c square into del 2u over del x square, along with the condition that ux0 equals to fx, which is known as the initial displacement if you remember, and utx0 equals to gx, which is known as the initial velocity. If you remember earlier in the problem which we solved by separation of variable, the length of the string is finite, but here it will be infinite from minus infinity to plus infinity. So initial deflection I am taking it as fx, and initial velocity, if you remember, ut del u over del t at t equal to 0 is taken as gx. In the earlier problem we have taken the initial velocity as 0, but here I am taking it as a function of x, that is gx. If this is the problem we are having, then the solution of this equation by DAlemberts formula is written as uxt equals to 1 upon 2 f of x plus ct plus f of x minus ct plus 1 upon 2c integral from x minus ct to x plus ct gx into dx. Student, try to remember this formula because most of the time this comes directly in the examination. This part is written on the basis of what? Fx, which is what? Initial displacement, and this is written on the basis of gx, what? Initial velocity. Now we are having two subcases for it. If suppose that in a problem gx is 0, that is if initial velocity is 0, so this part will be 0. So this part will be 0. It means what? The solution is taken only off from the part which is what? Only this one. If I am taking gx as 0. Once again, if suppose that fx is 0, if fx is 0, that is what? If I am taking fx is 0, that is there is no initial displacement or deflection. That is, I am taken fx as 0. If fx is taken as 0, it means what? The solution of this equation is taken only from what? Only from the gx. Means this term will be 0. Means this term will be taken as 0 and the solution is taken only from this term. So we are having two sub cases also for DAlemberts formula or solution. If both are the non-zero given, then the solution is given by this much, and we are having two cases. Case number 1, it says that if gx is 0, that is initial velocity is given as 0. Then from the equation number first, if you see, gx term will be 0 and the solution is 1 upon 2 f of x plus ct plus f of x minus ct. The gx part will be taken as 0. On the same time, if we are having initial displacement or deflection, that is fx as 0, then the solution will be 1 upon 2c x minus ct to x plus ct integral gx dx. What is fx here? What is fx? Fx is the initial deflection. We can put x in place of x plus ct. This will obtain. In place of x minus ct in place of x, this will obtain. So these are the two subcases of DAlemberts formula for the solution of one-dimensional wave equation. So according to what is given, we will apply these cases. Let us try to solve one or some problem on based of DAlemberts formula. Based problem. Find the solution of the following wave equation by using DAlemberts formula. Here you need to understand or remember one thing, that it is used for the solution of one-dimensional wave equation under infinite domain. The equation is given as a standard wave equation under the condition that ux0 equals to sin x, initial displacement, and utx0 equal to 0, initial velocity is 0. So just recall which formula should we apply? The formula which is given in equation number 3. I just go back, and so that is this formula which is given in equation number 2, equation number 2, because this will be tending to be 0 as gx is given as 0. So let us apply it. So what happened? I just apply the formula. So in this formula I am having what? The solution of the above equation by using DAlemberts formula is written as this much: 1 upon 2 f of x plus ct and f of x minus ct. Fx is given as sin x here. This is what? The term fx is given as, means this is we are taken as fx. This is taken as fx. So fx is sin x. So what will be the value of f of x plus ct? It will be sin of x plus ct. So put them in there. So uxt will be 1 upon 2 sin x plus ct plus sin x minus ct will be the solution of the given wave equation by using DAlemberts formula. You can see by using DAlembert you get the solution of the equation quickly. We can further simplify it by using trigonometric identity. So the solution will be sin x into cos ct. This is the solution of given wave equation. We can see the nature also. If I need to see that what is the nature of the deflection inside the wave at t equal to 0, let it be. This is the solution, that is this gives the deflection inside the string. Now I need to check what is the nature or how the deflection or string look like at t equal to 0. So I just put t equal to 0 if, then what I will get? I will get, just wait, if I put t equal to 0 in it, what I will get? I will get it as what? T equal to 0, so cos ct is 1, so I will get sin x. And if you remember the graph of sin x or what? The sin x is look like this much. Okay, let me make it correct. So the graph of sin x will look like this much, and in the same manner up to infinite. So this is the form of string at t equal to 0. Now we can analyze or imagine that how the string look like at t equal to 0. On the same manner, if I put t equal to 1 and let it be, I need to find the deflection at a distance x equal to 10 centimeter or 10 unit. Put in it and we get the deflection on that particular point. Let us solve one more problem on it. Find the solution of the following one-dimensional wave equation by using DAlemberts formula. Equation is given as del 2u over del t square c square del 2u over del x square, along with the condition that ux0 equals to mod of sin x and utx0 equals to 0. That is, initial velocity is given as 0 and deflection is given as mod of sin x. That is, fx is mod of sin x here. That is, in this problem fx is given as mod of sin x. Let us start. So the solution by using DAlembert formula as in the same as earlier one. Put fx plus ct and f of x minus ct. This will be look like this much. Use trigonometric identity. I will get mod of sin x into mod of cos ct. This will be the solution of the given equation by using DAlemberts formula. Remember, this is what the easy method or shortest method to find the solution. Now, once again, if I need to see what is the nature of the solution when time t is 0. So, if I put t equal to 0, what I get? uxt is equals to mod of sin x, and whose graph is lies in the upper half of the xy plane. It means what? At t equal to 0, the solution will be the graph of mod x, and graph of mod x will be look like this much. So you can see at the time t equal to 0, this is the form of the string, or we can say this is the shape of the wave that will formulated in the string at t equal to 0. Hope you will understand the concept. So this is how we can find the solution. One more problem for your practice. Find the solution of using DAlemberts formula for this equation in which the condition is given by these two. So try to solve this one and you will get your answer. So that's all for today's lecture, which is on DAlemberts method. Hope you will understand the same. So once again, thanks for watching. If still you are having the problem or having any doubt, you can ask for it.